Okay, I was asked to make a video on my algae talk, so I'm going to try to make this fast. That's why it's low tech here. And basically, I have this quote from the senior scientist at Monterey Bay Aquarium Research Institute saying algae is the only solution we've got if climate gets out of control. And that was published in the top science journal Nature. So that's focused on the oceans, and the Monterey Bay Institute is working with a research institute in Maine on what they call the biological carbon cycle in the oceans. And so they're using Argo floats and satellite data to study the amount of carbon that'll be sequestered by algae and the nutrient levels, the nitrate and phosphorus. And so if we look at, there's 7 main ways we can use algae to sequester CO2. There's already several coal plants. There's one in Israel, one in University of Kentucky. There's an ethanol plant that's doing this. There's one in Spain. So these coal plants, you can capture at least 50% of the CO2 emissions from the coal. So that would reduce CO2 emissions by, say, 20% worldwide. And then you could either sequester the algae or use it for fertilizer or feed or whatever. And now there's a company in Australia that just commercialized selling seaweed to cattle ranchers, and that reduces the methane emissions by 90%. And then there's also using the wastewater treatment plants. So pretty much there's like thousands of wastewater treatment plants in the US, and they're energy intensive to operate. But if you use algae, that will clean the water, and then the algae can be used for biofuel or animal feed, or you could sequester it. And so that would save money and clean the water. And then the biggest one is the fake whale feces algae marine biomass regeneration. And that has a goal of 35 gigatons per year to sequester the carbon. And then there's the company Brilliant Planet, and they have near ocean algae farms to mummify the CO2, and that would be a goal of 10 gigatons per year. And the guy who runs that is Raphael Jovine, and he has 2 PhDs in marine biology. So the company Brilliant Planet, they already are set up in Morocco, and they're being funded to sequester carbon there. And then they had a test farm in Oman and another one in South Africa. And then they have near ocean desert land that they've like looked at around the world. So if they get enough funding, that's how they be able to do this 10 gigatons per year sequestered. So that starts to add up. And then we also have companies that are treating the toxic algae blooms, and the biggest one is using hydrogen peroxide, and that's being used in Florida and Virginia, and so that will sequester the carbon too, because it mineralizes the carbon. And then finally we have kelp farms, and so the kelp farms can sequester like at least 1 gigaton a year, because Germany realized that they can sequester all their carbon if they use the brown kelp that grows around, I guess it's around Germany. I didn't know it, but at any rate, obviously the west coast of the U.S. they're promoting kelp farming, and then they can sequester it off the ocean shelf so it goes to a deeper level in the ocean. And so this whole plan of algae is all based on the photosynthesis rate in the world. So even though algae is only 1/10 of the biomass of compared to the land biomass, it's 50% of the photosynthesis. So that just proves that algae is way more efficient at photosynthesis, and that's why it's also the best source of biofuel, because oil comes from algae. And because we've already killed off 4.5 million whales, or approximately, or at least 3 million, which is the minimum number, that was a big loss of the sequestering of CO2, because the whale feces fed the algae growth, which then got sequestered as CO2. So by replacing the whale feces, then the krill population would increase and the fish population would increase, and so the whale population would also increase again, and eventually the whales would just take over doing naturally what was done before they were wiped out. So we have 10 to 50 times better carbon fixation. Algae is 50% CO2 than any other organism on the planet. So it's also, if you're making biofuel, it's like 10 times better for biofuel, or it's like 10 to 20 times. It's better than growing crops. Algae's 50% protein. So it's by far the best source for food and for crops because of this photosynthesis advantage. So it's all based on photosynthesis, the entropy of energy on Earth, and this was first discovered by Joseph Fourier 200 years ago, and he called the infrared emission, he called it dark heat, and he published 200 years ago that the effects of human industry, quote unquote, would heat up the planet. So they knew about that 200 years ago, but algae has been on the planet for 3.5 billion years, and so it's probably going to survive whatever we do to the planet. So then, I mentioned this. We'll just go through the first one, that the study reported the flue gas-fed algae ponds can reduce 45 of greenhouse gas emissions, which basically saying they can capture all the CO2 from the coal burning. And you get a 40-fold increase in biofuel productivity and a 20-fold increase in food productivity from growing algae. So there's a company that I mentioned, University of Kentucky. They're already capturing the CO2 as a experiment research from coal burning. And then there's a company called Global Algae Innovations, and they're set up in Hawaii, and they have reduced the biofuel cost down to like $2 a gallon. And so they said that you can meet all of the U.S. fuel demands with land half the size of Texas by growing algae. And if you want to supply the whole world's fuel supply, you'd only need land 3 times the size of Texas for algae growth. And if you had that half the size of Texas, you would have twice as much protein as soy that's currently grown in the U.S., and you'd have 10 times as much protein as soy for the global fuel supply if you had land 3 times the size of Texas. So that just gives the fuel and the food difference from algae. And so by treating the wastewater, you could sequester that. That would be another 15 gigatons per year. So that brings us up to like 60 gigatons, because you have 35 in the ocean, then you'd have 15 from wastewater, and then another 10 from near ocean farms in the desert. So that's 25 and 35 is 60 gigatons a year, and we're currently releasing 40 gigatons a year, so that would put us in a negative carbon plan just purely by growing algae. So the Sir David King, his quote is, "My ambition is to cover 2 to 3% of the deep ocean surfaces every year with the synthetic whale feces, and that would sequester 35 to 40 gigatons per year." So then the other video I showed was on Professor William H. Calvin, and he's a neurobiologist, and he apparently he's just reiterating what James Lovelock also recommended, was to have some kind of pumps in the ocean, and they can just be wave powered big tubes that would then cause the nutrition. That would make sure the carbon gets sequestered fast enough so it doesn't just get emitted back out of the surface, because otherwise you'd only sequester like 1/4 of the CO2 from the algae, because it gets eaten by the krill, and then it'd get emitted back out of the surface as like methane or CO2. So you'd have to add some kind of pump, like wave powered pumps. And so there's a company in California that's already engineered those wave powered pumps, and so they're saying you can also use those wave powered pumps to power desalination plants. And so that would be used, because desalination, it's otherwise too energy expensive to desalinate salt water for fresh water, but so that would be another way to fix the global water crisis to provide fresh water, is to use the wave pumps also for powering desalination plants along the ocean. So that pretty much covers there's questions about the fertilize using volcanic ash for the fake whale feces, and they've already proven by satellite that the volcanic ash causes the algae blooms, and so the volcanic ash has various nutrients that are otherwise limited, like magnesium, or let's see, what was it? Well, you have obviously it's a good source of iron, but the studies they've done says it does have enough phosphate to trigger the algae blooms. But there's some other micronutrients that then get resupplied to the ocean from the volcanic ash. So the paper here is on academia.edu, so anybody can read it for free on my academia site.